do is show you how to graph this. And I'm going to kind of show you two different ways we can graph this. First thing you need to always remember is, what does an absolute value function look like? Well, absolute value function, if you guys can remember, is going to be what we kind of call our V graph. Okay? So if that's our general form with the, across the point 1, 1, across the point 2, 2, negative 1, 1, so it's also symmetrical, all right? So one thing if you can remember your transformations, whenever I have a plus 4 inside of my function, what that tells me to do is shift my graph to the left 4 units. I don't have anything outside, no k, so it's not going to tell me to shift up or down. And I don't have a negative x or a negative of my function, so I'm not going to be reflecting the x nor the y-axis. So therefore, really just to graph this, I'll do it over here. What I'm going to do is I'm just going to take this whole graph and shift it over 4 units. So if here's what my graph originally looked like, and I just shifted over 1, 2, 3, 4 units. I'm sorry. So that's what my graph is going to look like. All right, now let's go and prove that. How do you know this is shifting left 4? I thought add 4, that should go to the right, right? It makes sense. Well, let's take a look at what the graph would look like. So let's pick some points. Let's pick x and y. And one thing I would like to do to graph this is I would say, well, let's pick, if I know negative 4, let's pick, how about negative 6? Let's pick negative 4. Let's pick 0. And let's pick 2. Okay? So now let's plot those on this graph right over here. 1, 2, 3, 4. 1, 2, 3, 4. 5, 6. 1, 2, 3, 4, 5. Okay. So if I was going to pick up, let's do f of negative 6, or h of negative 6. So h of negative 6 means negative 6 plus 4 equals, negative 6 plus 4 is a negative 2, which equals positive 2. So I'm going to put that in for there. So it's 2. So I go over to negative 6 and I go up 2. Then I go to f of negative 4, or h of negative 4. So h of negative 4 equals negative 4 plus 4, which is equal to absolute value of 0, which is 0. Then let's do f of h of 0. H of 0 equals 0 plus 4, which equals the absolute value of 4, which is equal to 2. I'm sorry, I forgot to do negative 4, 0. So negative 4, 1, 2, 3, 4, 0. Then I have 0, 2. That's not right. 0, 4. Absolute value of 4 is going to be 4. So I go 0 to 4. And then I go to 2. H of 2 is 2 plus 4, absolute value, which is going to equal 6, right? So 2 is up 6. Which I know my graph's a little rough, okay? But you guys can see it's the exact same thing. I had to shift it left 4, so that's why when you have the x plus 4, that tells you to shift it left 4, and I proved it by plugging in points. Now the last thing we need to do is we need to determine what is our domain and range. So our domain is going to say what are all the x values that this graph covers, right? Or that are defined for this function. Well, you can say this goes infinitely to the left and infinitely to the right. So therefore our domain is from negative infinity to infinity. There's always going to be an x value that's going to be a part of this graph. This graph will continue infinitely to the left. There means there always will be an x value for every point on this graph. However, for my range is a little bit different story. What you guys can notice is I have a y value for here, I have a y value here, I have a y value here. All points, as this infinitely goes to the right, it's going to infinitely go up. I'm always going to have a y value. However, I'm never going to have a y value below 0 because look at the graph never goes to 0. So therefore my range is going to be from 0 to infinity. So that's how you graph a absolute value function with a horizontal shift, and find the domain and range.